Today we're going to look at standard form and scientific notation. Scientific notation uses powers of 10, so let's take a look at that. We have 10 squared, or 10 to the second, which is actually 10 times 10, or 100. 10 to the third, which is 10 cubed, is 10 a factor 3 times being multiplied to get 1,000. 10 to the fourth would be 10 multiplied as a factor 4 times to get 10,000. So do you see the connection here? The exponent with a base of 10 is the number of zeros behind the 1. 10 to the second, a 1 with 2 zeros. Here we can take this scientific notation of 3 times 10 to the fifth and write it in standard form. Standard form is kind of like a regular number that we're used to seeing. So 3 times 10 to the fifth is actually 3 times 100,000. That's 10 to the fifth is the 1 with 5 zeros. Multiply and we get 300,000. So a nice little connection here is that we can just simply move the decimal 5 places to the right. So the exponent tells you how many times to move your decimal to the right. And it makes sense, we're making it a bigger number, from 3 to 300,000. Okay, check your progress. Express 5 times 10 to the fourth in standard form. Pause the video. So 10 to the fourth, which would mean to take the decimal that's behind the 5 and move it 4 places to the right. 1, 2, 3, 4. Fill in the gaps with zeros and add your comma. This one's similar. We're going to take 4.395, 4 and 395 thousandths times 10 to the fourth. Writing it in standard form means we're going to take that number times 10 to the fourth, which is 10,000, which is like moving the decimal 4 places to the right. And of course, we're going to end up with a bigger number because we're multiplying by a really big number, 10 to the fourth. So our answer is 49,950. Okay, check your progress. You write this scientific notation in standard form. Remember to pause the video. Multiplying by 10 to the 6th means moving your decimal 6 place values to the right. 1, 2, 3, 4, 5, 6. Fill in the gaps with zeros. Put in your commas every 3 place values for 2,614,000. In this one, we're taking 6 and 79 hundredths times a really, really little number, 10 to the negative 6. 10 to the negative 6 is 6 place values behind the decimal, really small. So we're actually going to move the decimal point 6 places to the left, making it a smaller number, which makes sense because 10 to the negative 6 is a very small number. Okay, check your progress. Take 8 and 3 hundredths times 10 to the negative fourth and write it in standard form. Remember to pause. To multiply times 10 to the negative fourth, it means we're going to move the decimal place 4 place values to the left to make it a smaller number. 1, 2, 3, 4. Fill in the gaps with zeros and put a lead 0 in front, so there's no question that this is actually a decimal. Without the lead 0, sometimes people don't notice the decimal and they think it was a speck of dirt. We can also take standard form and write it in scientific notation. We always want there to be one number to the left of the decimal. So we know that the 8 is going to be the front number, and our decimal is going to move from behind here all the way to behind the 8. So we can count, and we see that the decimal place moved 5 places. So we would write it as 8.0 times 10 to the 5th. The little exponent of 5 was because we moved it 5 place values over. Okay, check your progress. Change 65,000 into scientific notation. Remember to pause. Check how you did. Did you move the decimal from behind all the way so there was only one number in front of to the left of the decimal? So it was 6 as the lead. 6.5. We don't need these other zeros anymore. And we would say it's times 10 to the, well, how many place values did it move over? 1, 2, 3, 4. So 10 to the 4th. So what if we have a very small number, like 0.0119, and we want to write that in scientific notation? We still want there to be one number as the lead. So this number is going to be the lead in front of the decimal, and now it is going to be 1.19 times 10 to the something. How many places did the decimal move? 1, 2. So it's going to be times 10 to the second, but wait, this was a really small number, so this is going to be to the negative second. So that's an important difference. We had our small number, so this is going to be our small power of 10, 10 to the negative second. Okay, check your progress. Take this very small number and write it in scientific notation. Remember to pause. Check how you did. You want to move that decimal so there is only one number in the lead. We're going to have our 4 be in the lead. So 4.2 times 10 to the something. How many place values did it move over? 1, 2, 3, 4 place values. And remember, this was a really small number we had, so our power of 10 has to be very small. It would be 10 to the negative 4th. We're going to look at the diameters of these planets, and we're going to order them from greatest to least. So the first step would be to look at them according to their exponents. Saturn has the greatest exponent, so it's going to be the largest. Then those with the same exponent, we're going to compare the factors. So the 5 and 1/10 is greater than 4 and 9/10. So that tells us the next order. So the order is Saturn, Uranus, and Neptune. Okay, you check your progress and ordered the diameters of Earth, Jupiter, and Mercury from smallest to largest. Remember that the smallest is going to have the smallest exponent to the power of 10. Remember to pause the video. So Mercury is going to be the smallest one. It was the third one listed, and 10 to the 7th is smallest. After that, these two exponents are the same, so we have to look at the factors in front. The 1 and 5500ths would be the next smallest, and that would be Earth, followed by the largest, Jupiter.